Welcome back, students. Now let's study derivative problems. We went through limit rule problems, and these kind of problems almost guaranteed to show up in any exams. Graph problems, those are, I'll say, about toss-up, half and half. A little bit higher probability to see these kind of problems, and then maybe a little bit less than half probability to see these kind of problems, kind of averaging out as half and half. Now the derivative problems, well, it's 100% certain that you'll see a number of derivative problems. Exactly what kind of derivative rules you're going to be using, that's a little bit different. And here in this particular exam problem set, we have to use product rule, and this is chain rule, as a matter of fact, double chain rule. And then we have, what can I say, a more complicated problem. But to my surprise, as a matter of fact, students did better in the third problem than in the second problem. A bit surprised, as a matter of fact. First problem, very few students had any kind of trouble here. Okay, let's do this. Let's do this. And okay, let me just go ahead because the derivative of x is just 1, so minus 1, no problem there. And this part is going to be product rule. So just apply product rule and simplify, and that's it. And here we go. How about this x log of x part? And then this minus 1 part. And then the minus 1 part is nothing more than this. And then this product rule part is here, which I'm highlighting in blue. And then do you see how things are going here? So this is u times v. So u prime v plus uv prime, that's a product rule. And then what's u prime? The derivative of the first function is just 1. And then what's v prime? Derivative of log is 1 over x. So if you put everything together, what do you get? 1 log of x plus x times 1 over x. And we have a simplification, log of x plus 1 minus 1, and in the end, the answer is log of x. By the way, please remember this end result, because later in this semester, we're going to do antiderivative. We're going to go backward. And then, for example, taking the antiderivative of a power function is easy, and we simply have to backtrace the power rule. And then about trig functions, they're not too bad. Sine becomes cosine. That was derivative, so antiderivative, we just go backward. But log function is a bit of a problem, and this happens to be the antiderivative formula for logarithm. Okay, all right. Now let's go to the next problem, trigonometry problem. And this is actually a combination of two problems, blue problem and red problems. And you can find out the derivative of this blue function, cosine squared of 3 theta, and the derivative of red function, sine cube of 2 theta, separately using the chain rule, and then subtract one from the other in the end, if you're not really comfortable with doing everything at the same time. Okay, ready? All right, let's begin doing the blue problem. Cosine squared of 3 theta. Let's do this. And then please note that this is a shorthand of this. You see, you have to use chain rule, so you have to find out the outer function first, the derivative of outside function, and then go in. That's the rule. Outside first, and then going in. And outside function may look like cosine function, but no, it is not. Outside function is second power function. Cosine is inside. So if you apply the chain rule, what happens? Derivative of the outer function, and then whatever stay the same, and that's the structure of the chain rule. So derivative of the outer function and then inside always stays the same, no change there, ever. And then you have to multiply the derivative of the inside. All right, what's the derivative of the inside? Let's just take a bit of a pause, and then let's just put it as u prime. And let's take the derivative of this. Cosine of 3 theta. Oh, it's another composite function. So we have to take the derivative of the outer function first, and then going in. What's the derivative of outer function? What's the derivative of cosine? What's the derivative of the outer function? Negative sign, and then inside always stay the same. And then what's the derivative of the inside? There you go. We use the chain rule again here. Do you see that? Derivative of the outer function, and inside never changes, and this is the derivative of the inside function. Let's simplify all that. 2 times, oh wait a minute, I just made a stupid typo here. I mean, this should be 3 theta. Sorry about that. So derivative of 3 theta is 3. Okay, sorry about that. I just mistyped it. Yeah, I must have mistyped, and then after that I read the previous mistyping. Anyway, I found it before it's too late. And then let's do some simplification. If you stop here and then go over to the next step and then just put them together, you're going to get full credit. But I'm a teacher, so let me be perfect here. So let's simplify. 2 times 3 is a negative 6, and then cosine of 3 theta times sine of 3. And that is the derivative of the blue function. Let's see, let's do the derivative of the second function, the red function. Okay, it's similar, but instead of just leaving to you, let's do this. And if you're going to do this alone, you can stop this playback and then do it, and then you can come back. Okay, how do you handle this? Again, please note that the outer function is not sine, but it's cubic power function. So that's the outer function, and then now I'm ready to apply the chain rule. So power comes out, subtract 1 from the power times derivative of the inside. That's just structure, isn't it? And then what happens to the inside? Inside always stays the same. So you started off with sine of 2 theta. Okay, it'll stay as sine of 2 theta. Now here I have to take the derivative of the inside, derivative of the sine function. But let's take a bit of a pause here. Okay, and then let's go ahead with a derivative of sine of 2 theta function. If you're experienced, you can just go right ahead. Okay, what's the derivative of the sine of 2 theta? Chain rule again, so derivative of outside function. So derivative of sine is cosine. Oops. I clicked the wrong key. And then inside never changed. And times the derivative of the inside. Are you with me here? Inside never changes, and the derivative of 2 theta is 2. And let's do simplification here. 2 times 3 is 6, and then sine squared of 2 theta times, oh, typo here, squared, and then cosine of 2 theta. And that's the derivative of the red function. All right. Let's complete the problem. So this one minus that one. So we have blue function minus red function. And then this subtraction was there before. Missing some signs, pluses or minuses, no big deal. And then missing some multiplications, and then instead of getting 6 here, some other number, minimal deduction, kind of like 9 out of 10 kind of thing. Now, if you miss the outside function, and then instead of using 2 chain rule, just 1 chain rule, something like that, that's going to be a little bit more severe penalty, like kind of 3 points off. So if you lose 3 points and then 3 points there, and that's going to be 4 out of 10, yeah, it's still not bad considering the difficulty of the problem. But in any case, here we go. Now, as for the powers of trigonometric functions, sine squared, cosine squared, sine cubed, cosine to the 7th power, whatever, those kind of functions are so typical, and they appear in really a lot of places, and a lot of mathematics too, but in a lot of applied mathematics as well. So we do a lot of those kind of things in calculus courses. You have to get yourselves ready. Anyway, this turned out to be quite a bit difficult problem, and actually it turned out students had bigger trouble in this problem than the third problem, which was a bit of a surprise. Anyway, here's the end, and then, well, you can look up the answer key if you want to. Okay. Okay, let's go to the third problem. No, I better stop here. I'll stop here and then let's dump it over to the third problem in a separate video. See you soon.